Certified Penetration Testing Professional, Module 1, Introduction to Penetration Testing and Methodology. So our objective here is to learn the various fundamental concepts about penetration testing, including its importance, types, process, phases, and methodologies. So the first thing we're going to cover is the penetration testing concepts. It's a security test that evaluates an organization's ability to protect its infrastructure. And when you think about a penetration test, it's a focus of we're mapping the attack surface and trying to determine if the controls that the organization's put in place is mitigating the risk from that attack surface. Because all organizations will have an attack surface, and that attack surface equates to a risk. So that's kind of what we do in a penetration test, and we simulate an attack. And it's giving you an attack similar to what you're going to see with real attackers. And what are we looking for? We're analyzing and looking for design weaknesses, technical flaws, and vulnerabilities. And then from all this data, when we do all this different testing, we create a list of findings. And that findings is a comprehensive report that we give to the client and technical audiences, both executive management and the technical audiences. So what's the benefits? Threats and probability of an attack is a big one. Ensures the organization's operating with an acceptable level of risk, right? Determining the feasibility of a set of attack vectors and the potential business impact of a successful attack, right? And why do we do that? Because we want to prevent an upcoming exploitation. And then, are our controls working? Are we using controls that are mitigating the risk? So if somebody does attack our environment, our controls will mitigate the risk of that. And then you might have to maintain compliance, PCI DSS, Sarbanes-Oxley, HIPAA, those types of things. And we can identify those vulnerabilities that are critical or high in nature, so it gives us vulnerabilities that we can prioritize and figure out a plan to remediate or mitigate those critical or high vulnerability risks. And we get to check our devices. We know we have firewalls, we know we have routers, web servers, those types of things. What is the attack surface when somebody simulates an attack? Moreover, what can they do with that attack surface as far as gaining access or causing loss to the company? In-house is when organizations have their own team. Outsourced, self-explanatory. Then we have penetration testing as a service, which is a cloud service. And then crowdsourced, where you have an open-ended pen test assignment, right? Those types of things. Different ways, different models, conventional model versus next generation, right? Different types of things. Penetration testing as a service is what a lot of people is trying to get organizations to accept. So what's the return on investment for penetration testing? Well, that's why we do it. We want to identify where the weakness is. And once we identify the weakness, we can actually let the clients know this is the problem. And that's how we get the actual sell of a pen test, where people want to use and do a pen test, because they see how by using the actual simulated attack, we're able to determine what the attack surface has with respect to vulnerabilities. And that vulnerabilities equates to, as we said, potential access, right? So that's the important thing, because most people, companies, stuff like that, they want to know what their return on investment is. And that's what we've got there as the example in the equation. ROI equals expected returns minus cost of investment divided by cost of investment. So an audit is usually just a policy and procedure check. A vulnerability assessment goes up to the edge of penetration testing, but it doesn't validate anything it finds. It just says you have a vulnerability here. It doesn't test that vulnerability to see if I can validate it. Moreover, if I can get access from it. And that's the whole key here. When we validate and we get access, then we're actually accessing the machine. And the penetration test is the whole process all the way through that also includes validation of vulnerability. And we get that validation of vulnerability by exploitation. So if we exploit it, then we gain access, and then we can tell them, not only are you vulnerable, I can gain access to your system. And when I get access to the system, this is what I can do. It's not a ticking a checkbox to meet security requirements. Penetration testing is a systematic process that you use to evaluate weakness and invalidate those weaknesses that you discover. Vulnerability scanning is a part of it, but it's not a substitute, because vulnerability scans do not validate the findings. It focuses on achieving goals, not on finding vulnerabilities. That's an important thing to understand. We want to achieve certain types of goals, and that goal is if I have this network segment, I use this different types of software, application, whatever it is, what's my risk of using that? Not if there's a vulnerability in it, just my risk of using it is the first thing we want to achieve, and say you've got this attack surface, this risk of this attack surface is because you're running application XYZ, etc. So types, goal-oriented objective penetration tests, right, the different goals. Maybe we want to get remote access. We want to access credit card information. We want to get domain admin access. Denial of service, deface a website. All of these are different examples of the types of goals you might have as part of your scope in your penetration test. And it depends on the organization and the discussions. Everybody has different requirements. But that's one of the main things you want to do when you're doing the assessment. You want to find out what's the goal of the assessment. What is the goal of the client for you to achieve by running the test? Compliance. Maybe they're just trying to see if they're compliant. PCI DSS, for instance. It could be a compliance penetration test. Or you could do an all-out adversarial approach where it's a red team. And a red team is an unannounced simulated attack where we're trying as much as possible to mimic the behavior of an attacker against the target environment, right? So might be a security assessment. It could be a lot of different things. Part of the Department of Defense goal, the red team, was to always know what the risk was. So if anybody connected into a different area, in the case of Europe, if you connected into that theater, when you connected in, what was your risk going to do to the rest of the actual constituents in that theater? And that's kind of how we did red teaming back in the 90s. So now we look at three main types. We got the black box, the white box, and the gray box. Different ones take different approaches. And to be fair, different ones have different costs. The black box is where you have no knowledge, right? Limited information. A lot of information. This is red team hacking, all that type of stuff, things like that. Usually you're given maybe a domain name, IP address, something like that. So as you can imagine, since I have nothing, it's going to be time consuming to get something. So when it's time consuming, that's usually going to increase the cost of the testing. And we got two types that we talk about. We got blind, in the methodology of a real hacker, right? And then double blind, where nobody knows it's coming, right? Very few in the organization know it's coming. But we're testing the monitoring to see what? Do they see when we're doing the testing and we're coming? In blind testing, methodologies, the penetration testing team has limited or no information, and it's time consuming and expensive. Double blinds, where we're testing it and very few people know about it. So that's the two main black box further classifications. White box is you're given everything. Complete information of the infrastructure to be tested. This simulates the process of companies' employees, tests everything across the board because we have the information. And by giving the information, we can help concentrate on looking for bugs and vulnerabilities more quickly. If we have to spend time scanning, as in a black box, finding all this information, that's time consuming. When we get a white box, we've already given that information. So once we've done that, we can put more time into it. In effect, it gives you a better time and a complete testing coverage. White box, as we said, the announced testing, attempts to compromise the system on the client network, stuff like that. And then you've got unannounced, where nobody announces it without knowledge of the IT security personnel, right? So unannounced means nobody knows. Announced means they know, right? Different types of things. Gray box is a combination of black and white. Has some information, but not all the information. Testing internally, those types of things. Applications, vulnerabilities, right? Those types of things. Mostly when penetration starts with a black box, they find little prior knowledge, and we conduct a thorough review. We need help. So we get a little more information, network architecture review from a client, and it goes into a gray box penetration test. Cost. Here's a comparison cost, and it's all relative. Black box, of course, the cost is expensive, but not expensive as white box, and the reason for that is white box gave us everything. So if white box gives us everything, we have to test everything. So the comprehensiveness of it is great, but it comes at a higher cost because we have to test everything that we're given. And then gray box is in between. So that's kind of the breakdown of the cost and the comprehensiveness. So which one do you do? Really depends on your goal, your time, and your resources available. Black box is usually something looking at actions of a real-world attacker. But white and gray is what usually gives you the most value, because when you do a white or gray, we have time to look deeper into the system than we do in a black box. And the main thing is the planning. You have to do careful test planning and understand the constraints when you have limited time and resources. Automated, of course, is running tools, running a bunch of tools. The problem is, if we run a bunch of tools, how do you know your tools are accurate? So there's open source tools, there's commercial tools, but there's no guarantee of your accuracy. Manual is the best, but unfortunately, manual takes high skill set, and manual is time consuming. So usually what we do is we do a blended. But you find out from the client, because if the client wants to pay less money, automated is probably the way to go. If they have and they want you to do it, you can blend manual and automated. And the more manual you do, the more time consuming it is. So a lot of organizations, right, they have tools. We have the automated tools, right? MITRE talks about they only get about 45% of the known vulnerabilities. So 55% of the vulnerabilities require manual intervention. And that's why the ideal penetration test is manual and led by human intelligence, because it's puzzle. Think of it as a puzzle. You have to go through a puzzle to figure out what's taking place. That's what manual testing does. The automated testing sometimes can get you to an area, and then you take over with manual from there. And it always depends on the resources, your scope, and your budget. Network penetration. Self-explanatory. We're looking at the network. We're looking at that attack surface from ports. What ports are open, what services are running, and can we leverage that to get an attack? And since it's network, we're going to have the firewalls, the routers, anything that's connected to the network that could be misconfigured. So we look at misconfiguration. Web application testing, we're looking for code. We're testing the front-end web applications. Do they properly sanitize and validate input, right? If they don't, then we know we're going to have injection vulnerabilities, broken authentication, weak cryptography, all these different types of attack categories, because web applications have been notorious weak over the years, and they always are. Social engineering is where, if it's part of your scope of work, you're going to try to use deception, trickery. You're going to trick somebody into doing something, right? That's what social engineering does. And then wireless, we're doing what? We're doing wireless penetration testing by looking for access points and finding the actual maybe unauthorized rogue access point, looking at your encryption, looking at if you're using passphrases. Are they strong passphrases? What type of technology you're using? It's all the same type of components. Mobile devices, now you're just targeting the mobile device. So if you're doing a penetration test on a mobile device, you're probably going to have to root it or jailbreak it, right? That's the way it works. You start looking for insecure and different types of policies related to bring your own device. Cloud penetration testing, we're looking at the actual protection of the data at rest inside of the cloud. Big type of thing. Do we know they're protecting our data when it's inside of the cloud? It's just another component, if you will, of different types of penetration testing. So what do we do? What's the process? Well, we need the scope. What will we test? Where will it test? And who will be performing the testing? And then the information gathering, testing the target environment, network configuration, topology, hardware, and software, and then reports and delivering the results. the vulnerabilities, categorizing risk as high, medium, or low, recommend repairs, right? Mitigation. If we find a vulnerability, mitigation techniques. Pre-attack phase, information gathering. Attack phase, testing and exploitation. Post-attack, documentation and reporting. These are our phases in penetration testing. And you'll see different variances and different guidance, but it's just an example here. So our methodology, EC Council has the LPT, the License Penetration Testing Methodology, IBM, ISS, McAfee, Foundstone. There's lots of different methodologies out there. The OSTEM, the NIST, the OWASP. Which one do you use? A combination is the recommendation. Look at the different methodologies, create an actual methodology based on a combination, and customize and tailor it to meet your environment. The methodology is critical because it's a step-by-step process. So when we follow that systematic step-by-step process, that gives us a standard manner we proceed at and gives us repeatable results. Anytime we do something and we do it in a systematic nature, it's a repeatable process. And since it's a repeatable process, we can carry that out over and over again, hence repeatable. It helps us plan our testing and attack strategy and the input gained in the initial phases of the testing process. So what is the LPT penetration testing methodology? Right here. Information gathering, scanning and reconnaissance, fingerprinting and enumeration, vulnerability assessment, exploit research and verification, and reporting. This is the mechanism used for licensed penetration tester, the tools, techniques, and procedures. So we got a process here that we follow when we do our penetration testing. And it's a good idea to follow that systematic structure, and this is an example of that. So qualities of a licensed penetration tester. Analysis. All the tools give you a bunch of data. Since all the tools give you a bunch of data, what do you have to do? You have to analyze that data. And this is where, unfortunately, most people don't spend enough time, because you want to analyze that data. Once you analyze that data, you're going to identify from that data what's the network look like. Remember the whole process. We map the network's attack surface. Once we map the attack surface, we start looking for information to discover vulnerabilities. Once we discover vulnerabilities, we start looking for weaknesses that we can leverage access to, right? And that's this whole problem solving we do, right? You're never anytime you do penetration testing, it's a team. You always have to remember that. You rarely do this as a solo or individual. So what you do is you work together as a team toward a common goal for a project. And that's how you learn. You always make mistakes. Learn from those mistakes. Everybody can make mistakes. And it's problem solving. You're trying to problem solve based on what the network's telling you. And that's the key here. I have to analyze the traffic from the network to see what the network's telling me. Is there a filter in place? If there is a filter in place, can I breach it? Can I bypass it? What can I do against that filter? That's all part of this analysis and problem solving in a holistic approach. They all come together, and that's how the process works. Here's our modus operandi. To be good, you have to do what? Constantly maintain your skill set. So you got to keep working with different types of things and keep organized and make sure you do what? Quality. And the best way to do that is systematic process. And when you do the systematic process, you document everything you do. Very important that you do documentation, because once you get all that attack surface, you build your target database, that documentation is what you write your report on. And the report is what's your showcase. That's your deliverable to the client. That shows the client it was worthwhile investing in you because you know what you're doing because of the report you produced. So notes always, you got to have, nowadays you can actually take notes, and a lot of people do it electronically. Voice recorders is a good thing as well, right? Record your activities. Share information. This is the biggest part. When you're part of a team, and most of these engagements are part of a team, make sure you work together as a team, right? And always be open to the fact that if you don't know something, say you don't know and you're going to research it. That's all about number 6 there, where it's available resources. You have to keep practicing this, and you keep working at it because it keeps constant changing. So you have to stay vigilant. And the way you stay vigilant is you keep running your own platforms. You actually get into environments and lab environments, and you practice. That's the way you stay good at pen testing. So what's some guidelines and recommendations for penetration testing? Parameters of the test. We said, what's the objectives? What do they want to have take place? All right? And then make sure you staff the appropriate team. And then, based on your cost, you figure out what test you're going to be able to run. And then that systematic process. That's that methodology. Following that methodology, as we looked at the LPT methodology as an example, that systematic sequence of steps. And then while you're doing that, you have to do documentation. So you got to document your results. And it's critical that you document your results of what's taking place when you're doing the test, because you have to go back to those results, as I've already said, and write findings based on those results. When should it be performed? Anytime you do changes in the organization, anytime maybe a new threat comes out, any updates or installation of hardware or software, and anytime your policy has changed. This is guidance of when it should be performed. Ethics, very important. We have to maintain that separation between a criminal hacker and a professional. So you only work with written authorization from the client or somebody who's allowed to give you that written authorization. Make sure you have a non-disclosure agreement. You never talk about a test outside of a testing circle. Never do. And make sure before you ever do your test, and number 3 there, you've tested your tools in an isolated environment. You have to make sure you know exactly what the tools do. In fact, I'll add to that, it's better if you write your own tools. That's the best thing to actually do with that. Inform the client about any risks that might emanate from the tests. That's important as well. Notify the client at first discovery of any highly vulnerability flaw. So what you normally do there is you have with the client and you have point of contacts to contact based on the different things you might see. So if you get a critical critical vulnerability or anything, you have a list of people you want to contact for that. Do social engineering tests, right? Those types of things, if it's part of your scope. And try to always, as we said, and we've said it once and we'll say it again, make sure you stay on the side of the ethical side. If it seems questionable, don't do it. Do not risk your reputation. Do not run a script that either you didn't write or you completely vetted thoroughly in a lab environment. You don't want to run any scripts without doing that. So evolution is the challenge for a penetration tester. You're in the world where this technology changes fast, so you're going to have to continually try to maintain your skill set. Conferences, workshops, training, all those types of things. Security groups, participate in challenges, those types of things. Build your own range, build your lab environment and practice. You have to constantly maintain your skill set, and it's a daily job, no doubt about it. You got websites, you got forums, you got libraries, bookstores. There's a lot of locations and areas you can get, and it never ends. As I like to tell everybody, I've been penetration testing since 1993 when we led the DoD Red Team. I never stopped learning on a daily basis because it changes so fast. So you have to commit to maintaining currency of your skills. Qualifications, networking, of course. TCP/IP, you got to know it like you know the alphabet. If you don't know TCP/IP like you know the alphabet, start there. And then you go into the exploits, the hacking tools, all that type of stuff. But it's mainly get that foundational skills, right? We got foundational skills courses, stuff like that. TCP/IP, Unix, Linux, scripting, all those are important things to do. And then look at MySQL, Apache, start doing what? Specializing. So once you get that foundational skills and you're comfortable with it, and like I said, you know TCP/IP as well as you know the alphabet, then you branch off and start studying the other stuff. Troubleshooting, of course, routers, firewalls, databases, operating systems, it continues. We keep needing these things all the time, right? We have to maintain our currency. Web applications, HTTP, HTTPS, you got to understand the different operating systems. It's what Unix and Linux, Mac, Windows. All these are skill sets you have to maintain. So you can get certifications. You can go get certifications for doing some of this stuff like that. Whatever works for you to maintain your skill set, because it's perishable. And if you don't use it on a regular basis, it will go away. Communication skills. You got to be able to communicate people because you're going to be part of a team. So as a team, we have to work together as a team, right? We have to make sure we can explain what the output or the report is telling to the client in non-technical terms. So presentation, report writing skills are essential as well. A good pen tester constantly researches, publish research papers, you publish your own papers, you maybe write books, you hold certifications, stuff like that, you present at conferences. Those all make for a good pen tester. And you do what? You maintain memberships like the IEEE, the ACM, Association of Computing Machinery. All these are different organizations you can maintain membership. OWASP, the Open Web Application Security Project, has membership as well. You need to be part of all these because there's no way you can ever remember all this stuff. You have to keep current and go and maintain your references. There's the famous saying, I don't have to know everything. I just either got to know somebody who knows what I don't or know a reference to look up what I don't know. And that's an important component to remember when you embark on being a professional tester. Responsibilities, penetration testing, risk assessment, define the goals, right? What is the goal of the test? Look for system vulnerabilities, justify the found vulnerabilities, validation, right? Penetration tester is all about validating those reports. And then you take all that data and you present that report to the client. Understand the security of the servers, the network system, firewalls, all those different types of things are part of penetration testing. That's why it's what we consider a comprehensive blended skill. Risks, well, there's always going to be a risk. The risk is going to be if you run a scan, something can crash. Another risk is the tester's probably going to protect your sensitive data. So you got to make sure you maintain your ethics and you understand that by scanning, you might take down an organization's services. It can happen when you scan. So make sure people understand that. If you're doing social engineering, make sure you have rules and boundaries of what is going to be happening. Do not exceed those boundaries. And make sure that you have non-disclosure agreements and those types of things so you know nobody talks about anything related to the test. Remember, it's company confidential information at a minimum for the client that you're testing. Types of risks, we got technical risk, target could crash, service could crash, loss of sensitive data, that's all technical risk. Organizational risk, right? Triggering an incident handling process, those types of things. Negligence of monitoring, disruption in business continuity, and loss of reputation. That's a big one there is organizational risks because you could lose your reputation. So we want to make sure we don't do that. And then legal risks, remember what I said, do not run script or code in any test that you haven't vetted or written yourself. Otherwise, you could come under legal liability. So all these are types of things that's risk to the organization, also risk to you as well. So these are the types of things. You can have risk to the organization, you have risk to yourself as well. So just be aware of all that when you do your testing and make sure you have errors and omissions or liability insurance. Addressing the risks, right? Denial of service, slow and controlled. If you've got an area that has critical systems or industrial control systems, stuff like that, don't scan it. Only scan things that you know can take the scan. That's why ideally you will have a simulated environment, but that's ideally. In most cases you don't have that. Don't do any exploitation or validation of vulnerabilities if it's in a critical infrastructure type system or a system that could actually do different types of things. You can do slow and controlled to make it slower scans, stuff like that. Don't use any default scans. Make sure you look for specific things. Don't run the default. Nmap by default, of course, does 1,000 ports. Be careful of all that. Perform interruptible testing, right? Look at different types of things. throttled. You can try to actually run scans, but you might be throttled from an IPS, those types of things. That's why we kind of want to do slow and controlled when we do it. But the best thing is isolation. Have an isolated environment of the real environment that you don't have to run in a production system and run against a production system, because there are risks. And when you run against a production system, that production system might crash. And always remember, some of these accounts have what we call a lockout functionality. That means it's going to lock you out from getting access. And this brings us to the module summary. So as you see here, penetration testing, as we introduced it here, it's going to test your security policies, your controls, your technologies. And a comprehensive pen test assures the organization's operating in what? Acceptable level of risk. And remember, all networks and systems will have risk. In our pen test, we're telling them, this is your attack surface. This is the vulnerabilities from that attack surface. This is your risk. And that's critical when we're doing this stuff. And then the methodology ensures that we exercise in a standardized manner that documented and repeatable approach for our security posture. And then finally, the methodology is crucial and critical. Why? Because it gives you defined steps and a process that you're going to follow and do what? Get data from it. And when you get that data from that, your job as a pen tester is to analyze all that data. And when you analyze all that data as a pen tester, you want to define what it means, right? And once you do that, you write up what we call a finding. When you write up that finding, this is the description of the finding, the analysis exposure of the finding, and this is the way you mitigate or you remediate that finding. That's our job as a tester. Our job as a tester is to go in, follow our systematic process. We covered the LPT methodology in this module. We want to find that, and once we find that stuff, what do? We use it to explain to the client, this is your risk. So following the systematic, and we usually want to emulate a skill set of an attacker, but following the simulated and emulated skill set, we discovered this attack surface. From that attack surface, we have this risk. Therefore, since you have this risk from that attack surface, do this, this, and this, and it will mitigate or reduce that risk. It's up to the client whether they do the steps we tell them to mitigate or remove or remediate their risk. As a tester, our only job is to tell them that they have that risk. It's up to them whether they accept that or not. And that's an important thing to understand as a certified penetration tester. And with that, we'll conclude this module here.